Hoshizaki, a leading manufacturer of commercial food service equipment for over 50 years, now offers ice machines designed to be the most dependable and serviceable on the market. Utilizing the latest state-of-the-art technology, Hoshizaki run tests every machine at the factory with 23 quality performance tests. This video will demonstrate the basic sequence of operation of the Hoshizaki KM Cuber, including a simple checkout procedure, preventative maintenance, and cleaning instructions. Before we begin the basic operation, let's look at some of the features and benefits that make Hoshizaki machines so dependable and serviceable. Regular maintenance checks and servicing are made easier with the KM Cuber's removable panels. The component sections are divided into separate compartments, free from the damaging effects of moisture. Separating the evaporator or wet section from the dry electrical components of our machines helps eliminate many problem areas. Dividing these compartments also helps insulate the heat generated by the compressor from the cold section, making the KM Cuber more energy efficient. Unlike other ice makers on the market, the KM Cuber's pump motor is housed in a separate insulated compartment, away from the moisture of the evaporator, reducing corrosion, bearing and winding failures. At the heart of our pump assembly is a more efficient permanent split capacitor motor. This assembly can be easily removed and rebuilt in the field. The sealed evaporator section has a smaller ice drop zone than other ice makers. During operation, positive air pressure helps to reduce the airflow around the evaporator, keeping airborne bacteria out and reducing algae growth. Many manufacturers build evaporator plates in welded sections of copper, which are plated with nickel or tin. Plating the copper is necessary for sanitation and to allow the ice to harvest properly, but it may flake and peel from the copper with age, contaminating the ice. The unique plate design of Hoshizaki's evaporator, with its stainless steel freezing surface and oval-shaped serpentine tubing, produces a crystal-clear crescent-shaped hard cube of ice, which displaces more liquid than square or diced cubes. Since pure water freezes first on the evaporator plate, minerals are left to run off into the reservoir, reducing scale buildup and saving frequent and expensive cleaning. Removable panels, separate compartments, insulated evaporator section, efficient rebuildable pump assembly, small ice drop zone, and unique stainless steel evaporator. Just some of the features and benefits of the KM Cuber that help make your job easier. Now, let's look at the basic sequence of operation of the Hoshizaki KM Cuber. When the power switch is turned to the ice position, the inlet water valve opens, allowing water to enter and fill the reservoir. The 1-minute fill cycle assures that the ice machine will not start until there is sufficient water, eliminating overheated pumps and compressor problems. After 1 minute, the controller board checks to see if the float switch is closed, and if not, repeats the fill cycle until the water level is sufficient. The float switch check also occurs at the end of each harvest cycle to ensure continuous automatic low water safety. When the switch is closed, the controller starts the initial harvest cycle, which runs approximately 2 to 3 minutes depending on ambient air and water temperature. First, hot gas from the compressor enters the serpentine coils of the evaporator while the inlet water valve remains open to assist in the harvest. This causes any ice remaining from the previous cycle to be released from the plate while water continues to fill the reservoir. Starting the compressor in the harvest cycle with the hot gas valve open provides a no-load start, better efficiency, and longer life of the compressor and components. When the thermistor senses that the evaporator temperature has reached 48 degrees, the solid-state defrost completion timer on the circuit board takes control of the remainder of the harvest cycle. During the harvest cycle, the inlet water valve brings water through the supply tube and down the center of the evaporator plates. This water flow also helps transfer heat from the serpentine coils to the stainless steel plates and pre-chills the water flowing into the reservoir. During the freeze cycle, water is pumped to the outside of the plates through the distributor tubes. In the freeze cycle, the hot gas and water valves are closed. As the self-contained condenser fan and pump motor starts, water is circulated up and across the outside of the evaporator plate and back down into the reservoir. The circuit board controls the freeze cycle for the first 5 minutes, providing short cycle protection. The float switch then assumes control to initiate the next harvest. If power to the machine is interrupted, the unit will always restart in the 1-minute fill cycle. Before the second harvest, a 10-second pump-out cycle occurs. As the hot gas valve opens, allowing gas to warm up the evaporator, the pump motor stops for 2 seconds, then begins again in reverse. This pumps out the water containing concentrated minerals from the bottom of the reservoir, through the check valve and out the drain. At the same time, water is used to power flush the float switch. For improved cleaning, the pump-out timer on the circuit board may be adjusted to lengthen the cycle to 20 seconds. It can also be adjusted to occur every 1, 2, 5, or 10 cycles. These adjustments provide the service technician with the flexibility to overcome some problems associated with the high mineral content present in some local water supplies. When the pump-out cycle is completed, the pump motor stops and the inlet water valve opens. Just as in the initial harvest, the evaporator is warmed by the hot gas defrost and water assist, clearing any ice left frozen on the plate as the reservoir then refills in preparation for the next freeze cycle. The water level in the reservoir always overflows the standpipe at the end of the harvest cycle. On top of the standpipe is a displacement cap, which pulls additional minerals from the bottom of the reservoir and flushes them. This cleaning action can be extended by lengthening the defrost completion timer setting. When the bin is filled with ice, the machine automatically shuts off until more ice is needed. Let's review the basic sequence of operation. The ice maker always starts with the 1-minute fill cycle. The initial harvest cycle clears ice from the plate, assures a full reservoir, and allows quick and easy compressor starting. After 5 minutes in the freeze cycle, the float switch assumes control to initiate the next harvest. The 10 to 20 second pump out cleans the reservoir every 1, 2, 5, or 10 cycles. The normal harvest is the same as the initial harvest and allows the flush to clean the reservoir at the end of this cycle. To perform the 10-minute checkout procedure for the KM Cuber, restart the unit and verify the operational sequence. Make sure that all components cycle on correctly, from the 1-minute fill through the initial harvest and into the freeze cycle. If a component fails to cycle properly, check that component and its controls for problems. If all components are operating correctly, allow the unit to operate in the ice-making mode for about 6 minutes and then disconnect the float switch at the circuit board. This initiates the harvest cycle. Check for correct pump-out operation by watching water flow through the clear tubing or out the unit drain. The following preventative maintenance checks will help keep Hoshizaki KM Series Cubers dependable and serviceable for many years. Clean the removable air filter. Service the water filter and check the water valve screen. Visually inspect for loose wires, oil spots, water drips, etc. Clean the exterior with a soft cloth and neutral cleaner. Clean and sanitize the water system and bin. Annual cleaning and sanitizing of the water system is recommended. More frequent cleaning may be required depending on local water conditions. Cleaning the water system is an easy procedure with the KM Cuber. The complete cleaning instructions are listed on the reverse side of the front panel. First, drain the reservoir by removing the standpipe on M models or drain plug on S series models. Mix the cleaning solution according to directions on the panel and then pour it into the reservoir. Hoshizaki recommends Hoshizaki Scale Away or Economics Labs Lime Away. However, the durable stainless steel evaporator plate will not be harmed by any commercial ice machine cleaner. Set the control switch to wash and turn the evaporator cleaning valve to the open or wash position. With these controls set, the pump circulates cleaner inside and outside of the evaporator plates. Since the inside pass does not collect heavy mineral deposits, allow the cleaner to circulate through the cleaning valve for about 5 minutes. Then turn the cleaning valve back to the horizontal position. This allows all the cleaner to flow on the outside of the plates where more cleaning is needed. Once the flat surface is clean, pull the distributor tubes out 3/8 of an inch to allow cleaner to flow down the evaporator ribs. When cleaning is completed, flush the water system thoroughly with clean, fresh water. Turn the control switch to the ice position. The ice maker will restart in the normal sequence of operation. This same procedure should be used to sanitize the water system. Mix a commercial ice machine sanitizer as per directions on the panel, or a 5.25% sodium hypochlorite solution. Circulate this solution for 5 to 10 minutes over the evaporator surface and ribs. Flush the solution from the machine with clean, fresh water before restarting the ice maker. We hope this video has helped you better understand the basic sequence of operation and checkout procedure for Hoshizaki KM Cubers. Call our toll-free hotline for further information on KM Cubers or other Hoshizaki products. Remember, the name Hoshizaki